Hello and welcome to today's webinar, New Approaches to Real-Time Application Testing and Performance Monitoring. I'm Frank Days from CoralSense, your host today. And on behalf of the team here at CoralSense and SOASTA, we'd like to once again welcome you to this event. Before we get going, I wanted to talk a little bit about the agenda for today's session. First of all, we're going to talk a little bit about best practices for monitoring your application and web performance through the holiday season. We'll then talk a little bit more about some best practices and some new testing and monitoring techniques which you can apply to improve the overall performance of your application. It will then be followed by an integrated demo of both SOASTA and CoralSense's product and follow it up with a Q&A. What we're hoping to do today is to keep the presentation to last around 45 minutes, so you'll have some time at the end of the hour. Please, along the way, please feel free to submit questions via the chat window. We'll try to answer them in real time as much as possible, and we certainly will do our best to answer them at the end. And finally, we'll be making the slides and the recording available tomorrow on coralsense.com as well as through SOASTA's various channels. Now I'd like to talk a little bit about our speakers for the day. First of all, Warren Elias, CEO of CoralSense. Also talking will be Brad Johnson, a VP of Product Marketing at SOASTA, as well as Dan Bartow, who's a VP and Chief Evangelist at SOASTA, who will be providing the demo today. And now, without further ado, I'd like to hand over control to Brad Johnson.
Frank, thank you very much, and everyone, just thrilled to join CoralSense for this presentation on really some common best practices for testing and performance monitoring around the season that we're really right in the middle of, but frankly, some of the biggest days are already wrapped. So probably the best way to really look at where we are is to understand how significant web and mobile retail is. So we all know we're facing the end of the year. We're getting probably very excited about the holidays, doing lots of shopping. And if you look at Forrester's estimates of how much of retail sales are going to be and have been on the via the internet this year, we're looking at $197 billion on the web. And I actually did a little bit of research just before the webcast, and we're going to beat that. So we're going to probably be well over $200 billion in retail sales. And what I really love about this particular chart is it makes us think about how much the impact of the way that we research our purchases cause traffic on the web. So $200 billion is significant. But 1.1 trillion in influence revenue, or essentially people looking and researching their purchases online, is just almost incomprehensible. And if you rewound the way we all thought to 10 years ago, these are numbers that none of us could ever even guess around. And moving forward, obviously, this kind of chart shows us that things are just going to continue to get more better in a lot of ways, right? Let's not let this scare us. I mean, the internet has changed. It has changed the way we do everything. And so let's now drill into a little bit of what's happened this year so far. So one day of the year that's really critical, of course, is Cyber Monday. And so pulled this data up just a couple days ago. And what I like about it is guess what? All the talk of the recession, certainly there's lots of issues still out there in the economy. But when you look at online retail, it's growing. And in one day, retailers reported $1.3 billion in revenue just on this one Monday. The traffic pattern looks the same, but we're 33% more revenue than last year. Very, very significant. What I think is even more indicative and more significant is that of that traffic, of that revenue, almost 11% came from mobile traffic, mobile transactions. And that, look where it's up from last year. So let's just extrapolate a few years forward, and we're going to be seeing significant amounts of our web retail business, and this is not just retail, folks. This is all online traffic, online consumer traffic. Is going to be via mobile. So if we take one step deeper and talk about the impact of specific mobile platforms, you can drill into just one platform, the app, the Mac platform. I'm calling it iCommerce here. And significantly, this was a big surprise to a lot of folks, I'd imagine. This over this year, the traffic is higher from iPads than it is from iPhones, but nevertheless, a significant amount of page hits. Do the math here, 10, 11 million page hits are coming from iPhone traffic. So if you look at just the scope of the retail revenue period, and then how we're accessing the internet, how we're buying our consumables, things are changing. And so when you think about preparing for performance hits, preparing for what's going to happen next year, we're going to grow 33% again next year, how do you even determine what is peak load? In the old days, when we had internal-facing applications, the internet was, a tenth of what it is today. We could anticipate a couple thousand users a minute at max. That could be 500,000 users a minute now. So how do we plan? Is it, do we take 100% of our traffic and that's good? Or what if we actually have a wild, wonderful day where our site hits 500% traffic? To go out of season, but we're heading into Super Bowl season. Wendy's had a 1,700% spike in traffic just on a Super Bowl ad. So how can we plan for peak load, and how much of that load should we anticipate is mobile traffic? And then just thinking about the scale and the capacity to support that scale, well, how do we choose the most important transactions to test? How do we actually know what users are doing? How do we actually know which the most profitable paths that users take? And what's the effect of all the other traffic that's taking place on the website while profitable users are trying to execute their transactions? And then to that question, you say, well, if we have to test to this scale, which system do we test in? Is the lab good enough? There's argument, is the lab kind of a dinosaur? No, but you need to test in production. But that is taboo for many, many organizations, or has been in the past. And then once you get all these things lined up, how do you find the issues? When you've got third-party applications, you've got different services, you've got all kinds of contention for integration in your sites. How do you find out, even if you can drive this load, where the problems are? Well, the answers are there. I mean, the answers are, if we have all of these issues, how are we now going to solve them? And so the answer to what is peak load is, well, or the approach you need to take is you have to test to these new limits. You can't leave behind the ability to understand what real success is going to do on your site, and you have to drive mobile traffic as well as web traffic. And you need to understand which transactions are most important, where you're going to test. We live in a continuous world. We live in a situation where if your competitor delivers a new feature or puts a sale on or adds a new capability, we respond within days. So you need to be able to understand in delivering new web functionality, how do we test this continually? And both from the lab into live production, and of course, how do you find these issues when they occur? So monitoring plays in extremely well and is a critical part of both being proactive in understanding what's going to happen, as well as being understanding on a day-to-day, minute-by-minute basis where your common transactions are. So let me turn over to Oren, who's going to talk about some of the best practices in monitoring, and then we'll tie it all together and pulling it together for testing, as well as the product demo, which shows you how Cloud Test Platform allows you to do this every day.
Hi everyone, thanks for taking the time. So I wanted to touch base on how monitoring best practices can actually help, whether it's in the UAT environment or in the production environment. And I think that we're seeing that the challenges of the UAT environment are actually much higher in demand in terms of monitoring and management for applications. Since typically in a production environment you would run just load, in a UAT environment, as mentioned, we'd get up to 150, 200% load, 300% load, and the requirements for low overhead and being able to track everything that's going on is much more important. The first best practice that we mentioned, I called it assume nothing. One of the first things that our technology is able to do is auto-detect dependencies in real time without any prior knowledge of the application. And in several cases, we went in and kind of saw this picture that you see before you here. You map out all the components. This actually builds up automatically after a few seconds. And the first thing that we mentioned that we noticed was a production server being accessed from a development environment, testing environment. In the first case that we saw this, we were actually presenting some of our findings, and the meeting kind of ended then and there. The guys went outside, came back after 30 minutes. What turned out was that they had no knowledge that the testing environment was accessing a production database, and they were actually being called in, stopping testing to go into a war room, not knowing that their testing, their stress test of 200% was actually crashing a production database. And that was the only relation between the time of testing and the time that things were actually happening in production. That's an extreme case, although we do see it quite a lot. But really understanding what are the different components, how do they interact, and quickly being able to see where the bottlenecks are is obviously critical for performance engineering during a stress test. The second best practice that we wanted to mention was that visibility really is important for explaining real phenomena. So real phenomena means, not focus on what's going on in the infrastructure, trying to assume it's an issue, but really coming from the test results or what we experience from the user perspective. In the past, we've seen a lot of cases where the best practice was taking a look at all the metrics that were calculated, for example, CPU, noticing a spike, and then trying to handle it without really understanding how that ties into certain aspects, certain users, certain transactions. I think one of the interesting stories that we had in the past was a network team that came back and was complaining about high network throughput. Everyone was trying to understand what it affected. Since user experience was fine, the application was actually scaling. And this is an example of focusing on phenomena that really doesn't affect anything material. The other way around is being able to understand every single transaction, classify them into transaction types and functional areas, or a different dimension of focusing on a specific location that's not behaving. So how do we move from just understanding that we have an issue to actually getting complete visibility into what the application is doing at that time? So these are two explanations where on the top what we see is being able to understand how the workload breaks down between the various components. In this case, understanding how a load balancing issue actually affects the workload and directly relates into the increasing response times being measured during the test. The bottom part actually shows what was the breakdown between overall network time, data center, and user experience for an individual location versus the others. And now it's very clear what caused that spike whenever the load went up above a certain threshold. The third best practice is to be able to take all this information, baseline, and compare it. This is something that's been a best practice in performance engineering for a long time. You take the baseline of a previous stress test, you compare it to the 150% of load. What we propose is, in this best practice is to extend that to actually capture all of the models of the application during the stress test and be able to compare not just the results, but also what was the model during the previous stress test and the existing one, or in this case, comparing 100% of load versus 150% of load. So in some cases, what we've seen was that certain changes that were done to the application architecture, for example, a web service that's been changed, and now instead of making 20 calls per request, is now making 45 calls per request, is something that's forewarning to what may happen in production with a different blend of transactions. So comparing, being able to create an application profile and model and compare that one next to the other is a key point. This kind of shows how that deep visibility shows an increase in the LDAP requests while all the rest of the models kind of change the same, directly affecting what happens when you go over a certain threshold of activity. So with this, I'll hand it back to Brad.
And while the transition takes place, you know, this is a really excellent example of where performance management means getting a solid understanding of baseline performance and answering the question, well, how do I even set SLAs? How do we even know what appropriate performance metrics to look at and where the thresholds are exceeded unless I do a significant amount of testing? And the first best practice that I want to talk about is really testing early. And what that allows you to do is build a significant performance testing plan that starts really in the heads of the developers. And for many folks, this is a relatively new concept. But it's critical, because how do we really know what service levels to expect if we haven't iteratively gone through and started taking even unit tests and component tests and scaling them up to a few users, leading into more significant performance, non-functional requirements all the way through development, so that as we add new levels of testing, we're testing for new objectives. So as we move downstream, getting closer to production deliverables or making changes in our production code and on our production systems, we know what SLAs to set. We know that we've tested to make sure that when certain levels of users access the system, we were protecting those SLAs that we ultimately were going to have to defend back in operations. And this is another kind of plug for, this is a full life cycle solution where you need to think about performance early, test in the lab, test as the code progresses, get into the staging environment, get access to production, and yes, even test in live production environments. Or you had a great example of where a test environment reached out to touch production. Well, we found that with customers who do this all the time, you know, it's a process where they get very comfortable in rolling in testing into a production environment. And when you have the right tools and technologies as well as platforms, you're able to test in ways you've never thought of. One of the best examples for the retail season has been One of our clients they did start early. They started about 8 months ago. And their plan consisted of 68 performance tests, which might sound aggressive for a lot of you, but we thought that made sense. They thought it made sense. But in reality, by the time that they rolled out successfully for Cyber Monday, Black Friday, they had executed 1,100 tests. And just the ability to quickly do that all talks to the cloud test platform and our ability to use scale. But it is important to test as frequently as you possibly can. And so that leads into the next practice, which is about testing realistically. There really haven't been means to test significant scales with realistic user behavior. Really, it's been because of hardware constraints. I need a lot of load generators, which were not available, and also software constraints, meaning I didn't have 250,000 users to be able to model, or even 1,000 users to model. So there were a lot of workarounds established, but it's critical that you test realistically. You build tests that act like users acting like humans. So coming in at an uneven pace, some spending more time on different transactions than others, building a real good mix, and then getting them up to scale the way you really expect them to, and from different locations. So whether it's a U.S.-based app with Southeast, Central, and West users coming in, or a global app with people from Singapore and Europe and South America. Thank goodness we have a new source there from the cloud as of yesterday. You need to be able to simulate that realistic scale. And finally, as we move forward, we need to be able to seek a single source of performance truth. And that is, the greatest example we have of that is a common situation where somebody's using some limited end-user monitoring solution where they capture a response time of 2.5 seconds, and alarms go off, and the entire ops team starts reacting and going overboard and trying to figure out what happened, what went wrong, how is this possible? And eventually somebody gets back to the development team who actually delivered the application, and the response time expectation was 5 seconds. And so it was never tested to be faster than 2 seconds, right? So a huge disconnect between what we're measuring and what we're rolling out, what we're building, measuring, and rolling out. So it's critical to have that single source of performance truth. And this is where the alignment between CoralSense SharePath and SOASTA Cloud Test makes terrific sense, because we're able to take that monitoring data and put it into the context of a large-scale performance test, or frankly, any scale performance test. And so to talk about that a little bit, let me just click. What SharePath is able to do for us is identify those most critical transactions. And if somebody could forward this deck for me, that would be great. Those critical transactions are the ones, as I said earlier, are the ones that are either most profitable for the business, which you would identify as obviously critical, but there's also ones that are risky to the system, that if a lot of users came in and actually did something, they may cause a crash. So the SharePath technology is able to help identify that, watch what's happening, and pull out those most critical transactions. And then with Cloud Test, you can model that user behavior and actually run tests that hit the appropriate scale at the appropriate time with that realistic flow. I love this little peak graph here. This is actually Oprah's Twitter stream during one of her shows. And it's a great example of how an event can drive a significant amount of traffic that you need to model and test for, because this is the way the real world behaves. And then ultimately, you need to be able to do that, and Cloud Test can do that for you, but you need to be able to drill into the actual source of the issue while that test is running, and of course, as you continue monitoring on from that point forward. So this really leads into a demonstration of the joint solution. So really happy to hand over to Dan Bartow from the SOASTA team, who's going to talk about how you can take and build one of those tests very rapidly, scale to any scale across any location in the globe, and then connect to the CoralSense surpassed data and solve problems quick. So I'll turn over to Dan.
Great, thanks a lot, Brad. I'm very, very excited to be able to give you this product demonstration today because I think what we've been doing at SOASTA and at CoralSense is just really on the cutting edge of performance engineering. And one of the reasons why I'm so excited to give this demonstration is that what I'm about to show you is not pre-canned at all. We've got a real instance of Cloud Test set up. We've got a sample application, which happens to be Sugar CRM. If you're familiar with Sugar, it's an open source CRM solution. So we set up an instance of that in the cloud, and we've got a real instance of CoralSense actually running out there, monitoring Sugar CRM. And what I'm going to do for you today is illustrate how our customers have been doing just what Brad said, which is tens of thousands of hours of testing combined for holiday readiness and just for overall application performance, excellence and high confidence. So what I'm going to do with you here today is you're looking at the Cloud Test welcome screen. We're going to actually walk through creating a quick test which lands on the Sugar CRM application and logs in. We're going to spin up some servers in the cloud through Cloud Test to use as load generators, and that'll get us those multiple geographic locations and customer experience vitals from around the globe. We're going to ramp that test up, and we're going to try to see if we can pinpoint any performance bottlenecks. And in doing so, we'll be able to look at real-time, outside the firewall performance data from Cloud Test, as well as then drill inside the firewall and show you all the beautiful things that CoralSense can show you in terms of the real user monitoring, end-to-end transaction time, that great topology graph that Oren was showing, and drill in and just see if we can find any transaction slowness. And again, this is not pre-canned at all. We're going to do this end-to-end. And the whole process should only take about 10 minutes from nothing to running a scale test and actually trying to see if we can find some performance problems. And so, this speed that we're about to illustrate is really how we can get, high confidence through iterative testing and really just push the boundaries of performance engineering. So I've been in performance engineering for a long time, and I really think what we're doing here is bleeding edge and just a beautiful thing. So again, what we're going to start with is creating a test. So what you're looking at here is the Cloud Test welcome screen. Cloud Test has a really neat facility for recording traffic. We do so through what we call Conductor. And what Conductor is going to allow us to do is intercept any HTTP or HTTPS message traffic that leaves my laptop for purposes of creating a test. So what this means is that, and actually underneath the hood, it's basically a sophisticated man-in-the-middle, basically an HTTP proxy. This is not a browser plugin. And this is really important because what this means is I can use any browser on my laptop that generates HTTP or HTTPS traffic, AJAX, any type of Web 2.0 technology. We'll be able to intercept that traffic. But it also means that I can use any thick or thin client application that speaks web, or even any mobile device. And this is really important. So I can take any mobile device, iOS, Droid, tablet, phone, and configure its operating system proxy config to point to the laptop IP address and port running Conductor. So if I go over here to recordings on the left, and I click on the new button up here, you'll see I have a list of various Conductor installs that I've spread around out there. But you can see the one that's running on my MacBook Pro is connected. So what's going to happen when I hit record is that anything that happens on my machine that goes out to the web on 80 or 443 is going to get picked up and recorded into a test. So this is the part of the demo where I find out if I close my email and iCal and all that good stuff, because those actually do make web services calls. And so you can see there's nothing streaming in here, which is great. So 0 messages. So what I'm going to do is I'm going to pop open a browser. You can see I've got my home page set to blank, because otherwise if it opened up to Google, I would record that traffic. And what I'm going to do is I'm going to paste in the URL for this Sugar CRM demo environment that we've set up. And I'm going to hit return. Now, the landing page is going to load up here just like it would for any user. So I'm actually walking through the steps of the test case that I want to record. But if I move this down a little bit, what you can see is that we've got a nice stream of traffic flowing into Cloud Test. So it's the PHP page, landing page, as well as all of the related assets that make up this page. JavaScript, style sheets, PNGs, and we're going to look at a little bit inside those requests in a moment. But I'm also going to walk through the login process here. And I'm going to land on the welcome screen for Sugar CRM here. So again, it's just a nice open source, fully featured CRM system. So you know, not really important what you're seeing on the screen here in terms of the content, just a different navigation and whatnot for a CRM solution. So, but for illustration here, I think it's great because it's kind of a typical app, landing page, login, and for e-com sites, you know, for a lot of the large retailers we're testing this year, a good portion of their users are return users when we model their traffic. So logging in is a key transaction, not just for retail, but for pretty much any online application. So we're done over here in Safari. Let's jump back to Firefox. And you can see we've got a total of 83 messages recorded. So let's go ahead and hit stop. So again, just on the test creation piece, the Conductor in SOASTA allows you to record any HTTP or HTTPS traffic from any source that has a configurable proxy. And when you've got it running on a laptop, basically anything that leaves your laptop is going to get converted into a test. So I'm going to take this recording and put it into what we call a clip. Now, we're very excited at SOASTA. We were recently awarded a patent for visual test creation. And so what you're going to see here is that as opposed to pretty much every other testing product on the face of the earth, instead of seeing a code environment where you're forced to write C or Java or Pascal in the case of BDL, what you're going to see here is a nice visual environment. And so we're going to kind of make a few tweaks to this test and have a test that's ready to run in just about a minute. And the way that we enable that is really through the visual test creation piece here. So you can see that we've got this nice stream of messages, top to bottom, that represent different things in the request stream that we made. So we've got the original index page that we went to that you saw when we requested in the browser. We've got the actual, so this resulted in a redirect. We've got the actual page here, as well as all the associated content. And what I'm going to do here is actually just take a quick stroll down the list here and look at the different target names. One very common trait for modern web applications is that the application, both the home page as well as various parts of the application, at least in the case of web apps, are made up of multiple third-party includes. So, you know, on the typical home page, there's, you know, right around 10 different includes for things like analytics, tracking, advertising, offers, reviews, all coming from different third parties. Now, in this case, it looks like pretty much all of these requests are coming from the Sugar CRM demo instance we put out in EC2. But if I continue to stroll down the list here, you can see I've got some other various things here in the message stream that are coming from other third parties. And most interestingly, I think here you can see Sugar CRM. If you remember back out here on the landing page, there's some stuff that looks like it's included from a different source, a news stream, some other stuff in here. So when I play this back in a minute, I don't actually want to hit these third parties. So what I'm going to do is I'm just going to clean up anything that doesn't look like it's from our EC2 instance. So here's our EC2 instance. And you can see I'm just selecting messages and just deleting. And this UI allows you to do very complex gestures visually. So I can multi-select, I can drag and drop, I can reorder requests. What I'm doing is I'm just pruning out those other third parties to make sure that we've just got that EC2 instance in here. And so what we've got then is homepage, a real think time. Apparently I waited about 20 seconds before I actually logged in as I was explaining what we were doing. So we recorded down to the millisecond of think time. Just to make this a little more uniform and generate a little bit more load when we play it back, I'm going to modify the think time to 5 seconds. And again, I mentioned drag and drop. So I can reorder these requests if I'd like to. Another thing I can do is I can tag these as individual transactions. If I were to play this back as is, we would get all of the performance detail of the messages that are in here. But sometimes you want to create specific transactions that represent entire click streams or even just wrap an entire page. So for instance, this index message, which resulted in a redirect, and then also included this other HTML page, this is actually all one transaction, which is the home page. So what I can do is multi-select these messages and wrap them in a single transaction. And in Cloud Test, there's no limit to the number of transactions you can have. So I'll give this a name. I'll just call it the home page. And then in the login action, we've actually got two elements here. And the reason why we have that is one of them is a post. So this is the post of the login information. If you remember, I typed in my username and password, so that's all down here in the post body. And then this was the actual landing page. So again, two requests which you want to be able to track separately. This one was actually the post. So I might want to wrap this guy in his own transaction and just call it the post, because sometimes it's only the post that's slow. And then this was the landing, but this all makes up what we call the login action. So I'm just going to wrap this in one more transaction. And what I just wanted to illustrate through doing this is that there's no limit to the amount of nesting, tagging, or different types of changing or modifying that you can do within the test. So you can create very complex tests. Now, this is a pretty simple example: homepage, login, and load the landing page. But it's actually very representative of common user behaviors. So nice little test here that lands on the homepage and logs in. What we need to do to be able to run this now is we just need to spin up some servers in the cloud and define a quick workload, and we'll be ready to generate some load and start digging into the performance data. To spin up some servers, I'll go back out here to Cloud Test Central, and you'll see that I have a navigation on the left-hand side that says Cloud. What this allows me to do, we call this the grid portion of the product, is define a grid of load generators out in various public and private clouds. And what this is actually going to do is I've plugged in my cloud provider account information. So we have integrations with all the most common cloud providers out there. So think of Amazon EC2, IBM's Blue Cloud, Microsoft's Azure Cloud, and Rackspace. And this simple UI here is going to allow me to define a grid of load generators from various cloud providers and various geographic locations. So I'm going to grab one load generator here in US East. I'm going to grab one load generator in US West in Northern California, which is San Francisco, and I'm just using the EC2 locations here for this. And I'll grab one more in Oregon. So this will give us 3 points of presence to generate this test from. And what's going to happen now is when I click on deploy, we make real-time API calls out to these cloud providers and request that they give us the number of servers that we asked for, and that they load our software. We will do some health checking and a quick benchmark, and then we'll load them into the product. And this whole process is happening in real time now and should take about 2 to 3 minutes. Amazon has a very fast and robust API for provisioning servers. So this should happen pretty quickly, and we'll get a real-time log of any connection failures or health check failures, as well as we'll be tracking the time here. So hopefully we can live up to my word of a 3-minute or less deployment on these servers. So, and you can see we've already got actually one of them. A blue bar means the server is allocated, and green means it's been health checked. Now, if you've done performance testing in the past, you'll know that what you're seeing here is huge for a couple of reasons. Number one, it's always just challenging to get load generators. If it's bare metal in a data center, then you're reserving time. Sometimes you don't always have enough, and you're sharing time with other engineers. And then that bare metal is typically in your data center. So what I'm doing here is I'm getting servers, and I can get any number of servers from various geographic locations on demand and from outside the firewall. So this is happening very quickly here, and this is, again, speed and scale for testing. This is how you get it done. So I'm not going to sit here and wait for this thing to finish, although in the short amount of time, it's happening so fast. It's a minute and a half already, and it's almost done. We need to do one last thing before we click play on this test, and that is we need to take this test and convert it into what we call a composition, and this is just the workload that we're going to run. This is how many virtual users, what type of ramp up, and what type of schedule the load's going to come in on, as well as the different geographic locations it's going to run from. So again, a nice drag and drop interface, and if you remember, we spun up servers in 3 locations. So I'm going to drop these on 3 individual tracks. I was playing around with testing this thing earlier, and I realized it's a smaller instance, the CRM app that we put out there. So I think we can cause some interesting performance behavior with probably about 20 or so virtual users. So I'm going to add in 8 virtual users from each of our 3 locations. That'll give us about 24 users worth of load. But that 24 could really easily be 24,000 or, in some cases millions of users, depending on the size of the test and the customer. You're only dependent really on how many servers you get. So with these 3 servers, we can generate probably about 3,000 users worth of load, about 1,000 users per server, which is just dependent on the test. So, but that would be more than enough to break this simple demo environment we set up. And as you can see here, we've got our grid ready. We went through, we health checked. We actually started monitoring on those servers. We actually use our own SOASTA monitoring technology to monitor the health of our load generators. So let me just share that to you really quick. When we're running a test, you want to make sure that your load generators are actually performing in a healthy manner. So you can see here that I've got real-time CPU, memory utilization, network, and disk I/O information about my load generators that are in the cloud. So we can keep an eye on this while the test is running. And this same monitoring technology, by the way, can also be used to monitor infrastructure under test. So along with the Cloud Test platform comes the ability to use this on your lab or production environments. So you'll get the real-time second-by-second data, surface-level data about your infrastructure, again, CPU, network, and disk, and so forth. This is our load generators, not the server that we're going to test, just to be clear. This is the load generation infrastructure. So 24 users worth of load. Let me come over here and wrap this up. And you'll see I clicked on this little people icon here to allow this loop, which will essentially run the test until we stop it. I'll define the geographic location on a track-by-track basis. Remember, we had one in East, one in West, and one in West Oregon. And I'll just put a slight ramp on it. That way, we don't blow up those 24 users all instantaneously. That is actually a valid test, which we ran, the connection storm test for some of our customers that had sales that were flipping live at midnight. Sometimes you want the load to just come flying in. Here, we'll do a nice gradual ramp up over the course of 1 minute. So ramping up to 24 users over the course of 1 minute, and we set it to basically play until we push stop. Now, it's time for some real fun. Let's blow something up, or at least see if we can get some very valuable performance data. So this is the fun part of being a performance engineer. But again, if you're following along, we just created a really realistic test, which hits the home page and logs in. We've spun up 3 load generators in 3 different points around the United States, Oregon, San Francisco, and Virginia. And I've just loaded that test out to those 3 servers, and I'm about to push play. And now, here's where the real fun starts. We're going to start to get real-time data, second by second, from outside the firewall through Cloud Test, as well as inside the application architecture through CoralSense. And we're going to be able to see a nice end-to-end transaction mix and just some real beautiful stuff here. So what I'm going to do is start to add a few dashboards into the product. So I'm going to add what we call our load summary. And this is a high-level helicopter view dashboard that's going to give you some interesting statistics like how long the test has been running, the number of virtual users, the average response time. I'm also going to add some of our deep dive dashboards, what we call page analysis. And this is going to be a nice deep dive down into the page and every element inside of a page. And then I happen to notice that we're getting a few errors, just a few, 4, like 1.4% of the overall messages. So I'm going to add our error analysis dashboard. And we'll start taking a look at the data. So we're ramping up over the course of a minute. The secret sauce in Cloud Test is that real-time analytics engine. So you're going to see second by second, we're populating this dashboard. The yellow area chart in the background here is our virtual user ramp. Remember, we configured a 1 minute ramp up, so you can see a nice steady ramp over the course of a minute. And this is our average response time, and you can see that it's pretty spiky. It started to flatten out a little bit here, but on average, it's about 2.3 seconds right here. So, and that's across every HTTP request, assets, style sheets, JavaScript, HTML. So very high level. Deeper and look at the individual pages and the individual transactions. So here, this average page transaction time chart is showing me, if I pop that legend out, it's showing the different pages as they were recorded, as well as the different transactions we tagged. So we've got home page, login, post. Those different transactions we tagged are now showing up in the real-time analytics. So you can see we're starting to get some pretty interesting data. We've got some flat lines down here, which are performing pretty well. And then we've got some of these really high peaks, like the home page seems to be taking a really long time. That's actually over a minute to load the page. Here we're getting index.php, which was, I believe, the home page redirect. So these are really slow. And the reason why there's no line here is because that means basically for the past minute we haven't gotten any response time data for those pages. So I think we're probably crippling this application already. And let's just take a look really quick at the different errors that we're getting. And then I'm going to show you how we can find out where the problem actually is. So it looks like we're getting some 404s, which is more of a functional problem. So this HTML page is coming back sometimes, the 404. That usually indicates that a piece of content might not be deployed to one of your web servers in the cluster. And now we're starting to get some connection timeouts here on the home page. Send was completed, but no response received. So clearly this test is starting to have some issues, and that's evidenced, again, by these long-running page times. So let me go ahead and stop the test. I could leave it running, but I'm afraid I might cripple the demo environment here. So very realistic test that we're doing here. So these are the individual page and transaction response times. Let's start to take a look inside the pages. So this is a tabular view of that same data that you're seeing up here. And what you can see is that the login page, that whole login transaction actually is taking about 2.3 seconds, but the home page is taking on average 13.5 seconds. So what I can do is drill into that transaction and then look at all of the different components inside the transaction. So you can see that initial index.php hit, just to try to land on the page, is averaging 39 seconds with a high of 114 seconds. So that's very interesting. But then once you start to get into the landing page, what's interesting here is that this is only about 12 seconds, and then things are looking a little bit faster. So this is a very granular view of the analytics. You're drilling down into transactions, into pages, and you can start to try to figure out where the slowness is. And what it appears is that in this end-to-end transaction, the login transaction, as well as just that initial page hit, is taking a really long time. Once we get down into the login transaction, though, it actually seems to be pretty fast. So let's see if we can find out a little bit more about why this might be happening. In order to do that, I'm going to jump over into our CoralSense integration dashboard. So let's see what CoralSense can tell us about what just happened. So this is the SharePath landing screen. It's a high-level dashboard, and it gives you some really cool information about transactions and their volume as well as their response time. This is on a 24-hour aggregation, so I'm going to drop it to the past hour. So you can see some interesting transaction response time numbers from the past hour. And then this is the volume chart right here, so transaction volume. So this demo environment was pretty much sitting idle for the better part of the first part of the hour. Then we had some little individual transactions, probably just single browses. And then once we started the test, we started to get some real volume. So in the past 5 minutes, 4 of those minutes while the test was running, you can see that we had a transaction volume of 28, total transaction volume of 8, cruising along. And then the split out between red and green is the red is the percentage of the transactions that violated the predefined SLAs. So not looking very good here. But what's interesting is the average transaction response time on the high is 3.2 seconds. That doesn't really match up with the 1+ minutes that we're seeing for some of the key transactions actually out there on the homepage. So definitely something interesting is going on here. CoralSense SharePath does a really great job of automatically discovering your topology, as Oren showed earlier. So I got this beautiful map of the topology showing the transaction flow from users to application servers to database server. And you can see the average response time, again, from user to app server, 2.3 seconds, app to database, 3 milliseconds. So nothing really looks suspect yet. If I want to drill down into the login transaction, I can do that. And actually, it'll show the breakout time of the application server time as well as the database time. And then you can start to drill down much, much deeper to try to figure out, even individual query performance time. So if I start to break down the application server time, which is the majority of that time, into the different transaction segments, you can see for the login transaction, this is the call that has been absorbing the most time. And then I can go and actually look at every individual execution of the login transaction. So here are some of those failed transactions, the reds here, throughout the window of the test. And then I can jump in and even look at the sequence view down to the individual SQL statement. But what's interesting here, though, is if you're following along with me, I'm not really seeing anything that looks like it correlates with the really, really long response times that we're seeing from the outside. What CoralSense here is actually telling us, and I wanted to show this to you actually because it's a little different than the partner webinar we did a couple weeks ago where there was a really obvious code problem. What CoralSense is telling us right now is actually, yeah, there were some transactions that failed SLAs of 2.2 seconds. This one took 3 or so seconds. Here's your query. This is the app server time in blue. Here's the database time. So really fast database response time, and we saw that out there on the topology map. So what the heck is going on? Let me just jump back out here and look at high level. Yeah, we've got some violated SLAs for the home page and the login transactions, but everything that we're seeing here is like 2 or 3 seconds. It doesn't look really horrible. So let me jump back up to Cloud Test and again look and see if we can find anything in the deep dive that shows that where the problem might be. So if you remember, the highest time that we saw was out here on the home page, this initial index.php call is taking 39 seconds with a high of, again, 114. So if I start to kind of look through this list, I see something that's really interesting, and that is average time to first byte and time to last byte. So time to first byte in the performance engineering world is an indicator of server responsiveness. It's basically exactly what it means. It's how long does it take to get the first byte of a request. So I requested the home page. How long until I get the first byte of what I asked for? And that average time is 39.9 seconds out here. So on a 39.901 second average response time, what this is telling me is that the architecture is overloaded at the front of the stack. Basically, I'm making a request into the web server, and it's taking me 39.9 seconds to get that initial request. And then once I finally do get it, the time to last byte minus time to first byte is basically 0. It's 0.001. And once we finally do get through, the page has actually come back pretty quick, 2.75 seconds, 2.5 seconds. So this is an indicator of front of the stack, top of the stack slowness. Requests are queuing up. The web server can't process the load of those 24 users. Things are piling up at the front door. And once they finally do get through, and this is an interesting performance problem. It's not the database. It's not the app server. I didn't want to, we didn't want to show the common kind of, things in here. What we're showing you is as a real performance problem that's not always easy to track, but with inside and outside the firewall visibility, you're actually finding something pretty interesting. I could have put a load balancer out there and 10 web servers and then showed you a code level bottleneck, but the reality is that problems happen all over the place, and the classic problem of what is causing the performance bottleneck, what's causing the problem, requires the type of visibility that you get through an integrated solution like CoralSense and SOASTA inside the firewall, outside the firewall, to be able to get that data. And if you're just testing in the lab, you're never going to be able to find something like this. Let me show you one last thing. If you remember, we spun up these servers from 3 different geographic locations. We split out all the data by geographic location in Cloud Test. So that means that if you're having a geographic performance problem, then you'll be able to see everything from errors to bandwidth utilization, all split out by geolocation. And since we're getting application-level architecture issues, this is going to be another indicator that the customer experience was slow from all across the globe, at least in this case, all across the United States. So similar patterns from those different locations, but it's not always the case. If your architecture happens to be on the West Coast or the East Coast, performance problems can creep up for your customers in a different part of the world. And that's another type of performance problem that can only be shown through testing from outside the firewall. So with that, I would like to say thank you and turn it back over to Frank so we can take some questions.
Great. Well, thanks, Dan. I do appreciate it. If we could go back to the presentation. I'm actually going to go back to my, sorry for a moment here. We have to get back to the presentation itself. If you guys can hold on for a moment, because we're just going to put the presentation, put the presentation back up and transition from Dan's demo back to our slide here. Okay. Just give us one moment here. Great. Well, just in conclusion today, again, just to summarize some of the points that were made in this overall presentation, that for all of us out there managing complex IT environments, that the landscape has in fact changed. The way that we both manage and roll out applications is quite different. The way that people are interacting with our applications are quite different. And to get ready for that, it really requires both testing early and testing progressively, and trying to build these test plans and these test systems in as realistic a manner as possible. When looking at these applications, make sure we try to look for the root cause phenomenon, try to have a decent idea of our baselines and ultimately compare to it and use tools that can help you do that. And in conclusion, from Dan's demo, eloquent demo of both SharePath and Cloud Test, having tools that can both handle the testing as well as the monitoring are imperative. Finally, as we've opened it up for questions, we're going to take in a moment. Just if you're looking for additional information about either SOASTA's products or CoralSense's product, the best way to really learn about both products is to try them. There is a free test version, a free version of Cloud Test Lite, which is available for download from SOASTA.com, as well as a free version of SharePath Real User Monitoring from CoralSense at realusermonitoring.com. The best way to get started and learn on both of these is to download it and install it and use it real and live. At this point, I want to fire it up and see what questions we have. Okay. At the moment, it looks like I don't have any questions. So on behalf of all of us here at CoralSense, as well as the team at SOASTA, thanks for a great demo, Dan, and thank you for excellent presentations, both Oren and Brad. If you have any questions, feel free to email us at info@coralsense.com or info@soasta.com. And thank you again for joining us, and have a great day.